So now we're going to talk about expected value, um, which is kind of like the mean, the central tendency. What do we? It's not really what we expect to have happen, but it would be what we would expect if we do it for a large number of trials. So let's go ahead and see how all of this works. We want to compute the expected value of this random variable um, e to the, so that's expected value. The expected value would be, since the values go from -2 all the way to 2, expected values have to be somewhere in here. Remember, this is a mean. And basically all we're going to do is we're going to take each value times its probability, and then we add those together. So it's really like a weighted mean, thinking of these as not just necessarily probabilities, which they are, percentages, but they could also be relative frequencies. So it's a weighted mean. It's really nothing all that new. The thing is with this one, we're missing two places. So we also have to remember that a probability distribution has no negative probabilities. You cannot have negative probabilities. And when we add them all together, they have to add to 1. Or which is 100%. Thinking of percentages, it makes more sense than just thinking of 1. But so we've got 2 that we don't know. So let's see, what we got? 0.4, 0.5, 0.6 when we add it together. So we have 60%. We want to subtract that from 1. 60 from 100, you can see how that works, is going to be 0.4 or 40%. We've got 2 slots. We're told that they're equally likely. They're the same probabilities. So we divide that by 2, and we get that each of them will be 0.2, 20%. So we'll fill those in, 0.2 and 0.2. Now we want the expected value, and one of the ways we could go about this, it's really just x times the probability that x equals little x for each of these. So we've got -2 times 0.2. We'll just multiply down this way each of these. 2 times 2 is going to be, I'm going to go down a little bit further. It's going to be negative, and negative times a positive. 2 times 2 is 4, so we get 0.04. -1 times 0.2, again, we're going to add that together, is going to be -0.2, right? 0 times 0.4, that's 0. 1 times 0.1, that's 0.1. And 2 times 0.1 is 0.2. And then we add all these together. We see we got -0.6, 0, so that's -0.5. We're adding things on, -0.3. 0.3. It's not a probability, that's an expected value. And so what we see is it's, what would -0.3 be? It would be somewhere between 0 and -1, a little bit closer to 0, right? So it would be about here. And you can see the weighting. There's more weighting down here in the negative round. Uh, the biggest rating's right here, sort of at the central 0, but it's a little bit left side heavy in comparison to here, which moves the mean from, if you just look at this, where's the middle? It's 0. That's the median, I guess you could say. Um, but, just without considering the weightings, we see the heaviest weights here right in the middle, which is good. Had these also been 0.1s, then it would be, this would have been it. But it's a little heavier on the left side, so it pulls the mean down to the left. Always good to be able to do that kind of a check. There it is up there, -0.3. So that, you get your answer, and if you made a calculation error, something, and sometimes a symbol is, 2 plus 2 and you get 5. So those things can happen because you're focusing on higher level reasoning, but make sure your answers are right in the ballpark. Okay.